Okay, guys, so a sequence. Do you guys remember sequences, series, summation, any of that from Algebra 2? Oh, I don't have any extras. Sorry. Yeah. Sorry. Keep going. It's near the end of the package. Yeah. We're only spending one day on sequences and series, so obviously we aren't going to go super in depth. It's still going to be kind of just a review of the general formulas you need to know. BC Calc, those of you that are going on to that, you will do a whole unit in BC Calc dealing with sequences and series, so thank you. So I just need to refresh your memory on what those are. Thank you so much. So we'll review some terms for you. So guys, first, a sequence is just an ordered list of numbers. Like 1, 2, 3, 4, 5, 6. That's a sequence, okay? Then the series, that's the sum of all of those numbers. So the indicated sum of all the terms in a sequence. And I will show you guys how to do the summation on your calculator in case you forgot. There's a nice little shortcut for that too. Okay. All right, and then a sequence or series, it's infinite if it contains an infinite number of terms. So if you see that dot, dot, dot at the end, that means it's going forever. That's infinite. Alright, so our first couple problems here, we're looking at series, so that means it's things being added together. We're going to write it with summation notation. Do you guys know what we use for summation? Yeah, the weird E, right? The sigma. Okay, so that's what we're going to do. Ooh, that's a terrible E. Let's try that again. Okay. And you can pick whatever variable you want. You see a lot of n's when we do sequences and series, but you can certainly write it with x's, that's fine. I'll start with x equals 1. That's where you begin. And since there's the dot, dot, dot at the top of my sigma, I'm going to write infinity. And then guys, what's the rule for this series? Like, what's happening here? Okay, plus 3, but how do we write that so that if I plug a 1 in, I get 3. If I plug a 2 in, I get 6. If I plug a 3 in, I get 9. Well, 1 plus 3 is not 3. No, it's okay. Like, I talk it out, see if you can come up with it. 3x, yes. Yeah, if you just did 3x. We're overthinking it. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. Everybody okay with that? Because you're plugging in right here. This is telling you the first thing I'm plugging in is a 1, then a 2, then a 3, all the way to infinity. Okay? You just have to make sure your rule will actually give you this term.
So you have to not start out with the 1?
You can. But for most of the ones you're going to write, and then once you start at 1, I may give you one where I say evaluate the sum, and it'll be like from 5 to 9 or something like that. But if you're writing the formula, you're usually start. Yeah, like I would give you, like here, evaluate the sum. See how this one goes from 6 to 8. That's really the only time you see it. Okay. All right. So far, so good. Okay, you guys write number 2. Write that with summation notation. We have our big sigma. I'm going to start with x equals 1. What am I going to go up to this time? 5. How do we know that? It has 5 terms, yeah, so 1 through 5, okay. And then what is my formula or my rule going to be? Nope, 1 over x. Easy? Okay. All right, number 3. You could do this by hand. So we're going to write it out, but then I'm going to show you how to do it on your calculator, okay? Make your life a little easier. So if you were doing this by hand, you'd start by plugging a 1 in. So we'd have 1 over 1 plus 1, and then plus. Plug a 2 in. 2 over 2 plus 1. Plus 3 over 3 plus 1. Plus 4 over 4 plus 1. Plus 5 over 5 plus 1. Plus 6 over 6 plus 1. Does anybody really want to do all those fractions by hand? There is a pattern. So let me show you on your calculator how you can just do this. And it's so much easier. Okay, so you know how we have the shortcut for the fraction key? There's a shortcut for sigma too. This is if you have the updated software, slightly newer calculator. All right, you're going to do alpha and then window. Do you see the second one? How it's a big E? That's the one we're picking. And guys, if you ever forget which little shortcut it's under, just try them until you find it, okay? It's not like the world will end if you hit alpha y equals and that was wrong, okay? Just keep looking until you find the sigma. So I'm going to arrow down, pick the sigma, and look at how nice that is. It looks exactly like what we've been writing. You just have to plug in the values. So x is easy to use, so that's the variable I'm going to use. And then in our problem, it was what, 1 to 6? So I'm going to do 1, and then up here I'll do 6. Okay. Go shopping. No, I'm kidding. There is a way to do it. Oh, thank you, Hannah. It's just not as user-friendly. Like, you have to remember the order of putting things in if you have the older one. Whereas this is just so helpful. Like, oh, there it is. There's my formula. And then I'm just going to plug in x over x plus 1. So again, use your fraction shortcut key. You could use I, but x is just a lot easier to key in because you already have an x key. No, it just means the variable. Okay? Yeah.
So like the n doesn't have to match the I.
So whatever you put here has to match what you have in here. Okay, so if you wanted to do n and n over n plus 1, or I and I over n plus 1, that's fine. You have an x key on your calculator, so that's why when I key it in, I usually just use x. It doesn't matter, but they do have to match. Okay. And then just push enter. And you get this lovely fraction of 617 over 140. Was that a little nicer than doing that one by hand? Yes, okay. Anybody questions on that? Does anybody else have the old calculator? Did you figure it out or not? No. All right, here, let me go back to the other screen, and I'll come over and help you. All right, so this one was 617 over 140. Okay, so you guys try number 4. So remember, you're going from 6 to 8 this time. series.
We're still on
All right, guys, what'd you get for this one? 27? Yes? Pretty easy with your calculator? Yeah? Well, for some. I'm just kidding. No, the new program is just so nice. All right, we okay? Okay, so we are now going to determine a rule for the nth term. So these keep going forever. We just have to come up with a formula. So we are going to say a sub n, because that would be the nth term. Like if you say a sub 3, that's the third term. A sub 7, that's the seventh term. So a sub n. And by sub, I mean subscript. You guys are with me? Okay. So a sub n equals, and then let's come up with our formula. What do you think? I think you have the right idea. You just have a lot of, e is not a variable, right? So I heard somebody say e to the n, which I agree with, over what? Yes. That is your rule. Okay? So you guys try 8, 9, and 10. Come up with your rule for the nth term. Alright, guys. Look up some. Alright guys, how we doing? You need another minute or are we good? Minute? Okay. Alright guys, so number 8, what'd you get for your a sub n formula? 2n minus 1. Good. Number 9, how are we doing with this alternating sign business? It's very nice, yes. There's a very easy way to do this. If your sequencer series alternates signs, you can do -1, and then either to the n or to the n plus 1, depending on if your first term's negative or your first term's positive. Here, our first term was positive, so I'm going to do to the n plus 1, because that gives me -1 squared for my first term, which is going to be positive 1. And then what's the rest of the rule? N squared, right? You guys see those are just perfect square numbers. Look at that for a second. Does that make sense to you? You see it? Yeah, so anytime your signs are alternating, you're going to have -1 to some exponent. Like if the first term had been a -1, then you'd have -1 to the n instead of n plus 1. You could use n minus 1 if you really want to. No, just... Okay. Any other issues with 9, or we kind of see it? All right. I think 10 is easier. What'd you do for this one? Yep, n over 3 to the n. Fractions, it's kind of nice. You can usually look at the numerator separate from the denominator and just find 2 individual rules. Okay? Not too bad? All right. Now we're going to look at a specific type of sequences and series. We're going to look at arithmetic first. Do you guys remember the other type? Geometric, yep. So we'll do arithmetic first. Arithmetic means there's been a common difference, or the same number added or subtracted each time to find a new term. So we have some specific formulas we can use for this. This right here, a sub n equals a sub 1 plus n minus 1 times d. You definitely need to know that one. A sub 1 is your first term, n is the number of terms, and d is that common difference. It can be addition or subtraction, but it's called the difference. All right, and then if we're looking at the sum of our arithmetic sequence, we have this formula, s sub n, so that means sum. Sum of how many terms we're talking about. I could ask you for the sum of the first 5 terms, 10 terms, whatever. N over 2, well, n is still the number of terms. A sub 1 is your first term. A sub n is whichever the last term is. Okay, and again, with examples, I think these will make sense. All right, so let's look at the first one down here. find the 10th term. So just to start getting these formulas stuck in your head, we're going to use the a sub n equals a sub 1 plus n minus 1 times d. We're looking for a specific term, so we're going to use the formula that deals with terms. So we are trying to find a sub 10. All right, I need a sub 1. What is my first term? 1 plus, okay, what's n? 10, so 10 minus 1 times, what is the difference here in my base sequence? Yeah, negative 3. You guys see it's going down by 3 each time? All right. So 10 minus 1, that's 9, times negative 3, negative 27, and then plus 1, negative 26. Yeah. You remember this?
Yeah.
A little bit? Yeah? Okay. Not too bad, right? Again, you got to just know those formulas. Okay. So next one here, the 8th term is 75, the 20th term is 39, and we have to come up with a rule. So again, we're going to go back to this formula, a sub n equals a sub 1 plus n minus 1 times d. I'm just making you write that over and over so it'll be ingrained in your head. So we're going to write this once for the 8th term and once for the 20th term. So a sub 8, the 8th term is 75, right? So I can do 75 equals, I don't know what the first term is, I'm going to leave that alone. This was the 8th term, right? So my n minus 1, that's 8 minus 1, or you could just write 7. And do I know the difference yet? No, so I'm going to do a d. But then I have other information about the 20th term. So the 20th term is 39, so 39 equals, again, I do not know a sub 1, but I know this is 20 minus 1 times d. You guys see how that's a system of equations? You have two variables, two equations, okay? Do you remember doing elimination? Where you could just add or subtract the equations. I'm going to just subtract them because that'll eliminate my a sub 1. So, what is 75 minus 39? 36. All right, the a's are going to be gone. And then this is really like 7d minus 19d. So what is that? Positive or negative?
Negative.
Yep. Okay, so we'll go up here. What does d equal then? Negative 3. And always check this. The 8th term was 75. The 20th term was 39. Does it make sense that my d is negative? Yeah, it's getting smaller as we go. Okay, so just think through those things. Make sure your answer makes sense. I'm not done yet, though. I have to find a sub 1. So I don't care which equation you plug it into. I'll do the first one. 75 equals a sub 1 plus 7 times negative 3. So we're really going to be adding 21 to both sides. You guys okay with 96 for your a sub 1? You're still not done. You have to actually write the nth term rule. So please don't find all the pieces and then forget to write the final answer. So we would say a sub n equals 96 plus n minus 1 times negative 3. That is your final answer. Bless you. You could multiply that out and simplify it if you wanted to. You can leave it like that. I'm good with it either way. Okay. All right. Number 3, I want you to find the sum of the first 49 terms of this sequence. I want you guys to try this. You absolutely can use your calculator. Alright guys. So if I wrote it with the sigma, if I wrote my summation form, I know it's an n, I'm going to change it to an x just for ease of putting it in your calculator. Do you agree that 1 through 49 would give me the first 49 terms? Okay. And then up 3x plus 5. You should get 3,920. Anybody having calculator troubles? Go ahead, you get it? Try this one real quick, just to practice that. Does anybody else have the older calculator and I've been ignoring you? Yes? Okay. Yeah, because you have to do sum parentheses, sequence parentheses, the rule, comma, the variable, comma, below, the high, and what you get. No, it's terrible. It's so much easier on the You can actually update the software on that calculator so that it is the new one. If you, I know today is the state of Warthog time, but if you want to come, Ms. Crocioli has the cable and can update it for you. Because then you have all the nice shortcuts and everything. Okay. Nice. Yeah. No. Really, like the 83s we can't, but that is, yeah. Alright guys, we good so far? Okay, let's go on to geometric then. Alright. So arithmetic was when you were adding or subtracting things. Geometric are when you're multiplying by some ratio. If you ever need to find the ratio, that's this formula right here. A sub n over a sub n minus 1. That means if you take any term divided by the term right before it, you'll get the ratio. Okay? So if you ever need to find it when you're given, like if you look at this rule, if I need to find r, you can always do like 3/4 divided by -1. That will give you your r. Okay, so a term divided by the term in front of it. Okay, then we have some other formulas. Here is your formula for the nth term. It is the first term multiplied by the ratio to the n minus 1. And then the sum of your terms, S sub n, that's given by first term times 1 minus ratio to the n over 1 minus your ratio. Okay?
So those eights are the first term?
Yep. There's not, I know, you could put a little 1 in there just to remind yourself, but yeah, that's definitely first term. So just A, it says right here, first term is A. Okay, just so you know, that's what we're looking at. Alright, so let's try to find the nth term rule for this little series here. So if we're doing nth term, we know we're going to do a sub n, and it's a times r to the n minus 1, just again practicing those formulas. Alright, so what is the first term in this series? -1. All right, we have to find the R. Some of you will just see it. It's so interesting every year. Some students just see these formulas, see the patterns. That's awesome. Some of you are like, no, I need a formula. I need a process that I have to go through. That's fine too. Like, whatever makes sense in your head. If you need to actually find the R, remember we can do one term divided by the term right in front of it. So what is 3/4 divided by -4? -3/4. And if you pick different terms, like if you're like, nope, I really like 27/64 divided by -9/16. That's fine. You're still going to get -3/4. Okay? That is your R. And then we just write to the n minus 1. Okay, so let's do the 10th term. So we've got our rule now. So if we're going to find a sub 10, that's going to be -1 times -3/4 to the 10 minus 1, or you can certainly just put in a 9. See what you get on your calculator. It is a lovely fraction. I would like the fraction. So you could do -3 to the 9th, and then you could do 4 to the 9th. Multiply that in, you know, make that a fraction, and then multiply it by -1. Okay, order of operations. I'm glad you asked that. Guys, remember, don't multiply by the -1 first. Order of operations. We do that exponent first, and then times -1. Because remember, every other term will be negative here, so. So is this fraction negative or positive? Positive, good. Anybody think they have it? It's a nice big number. No. I would like a fraction. Tini, what do you got?
19,683 over 26214. Wait, 144.
So 262,000. I know, it's so funny when numbers get big. People are just like 71984. Calculator doesn't put commas. It's very hard. 19,683 over 262,144. So Claude, does that make sense what I'm saying, how you can get the fraction? You just have to do it in parts. I know it's annoying. All right, we okay with that one? Okay. Next one, we are going to find the sum of the first 15 terms of this sequence, 2 to the n minus 1. So let's jot down our formula if we're doing sum. S sub n equals A times 1 minus r to the n over 1 minus r. That is not written well. Sometimes my r's and n's look the same, and that's just not good. Okay, so we clearly need our n, we need our a, and we need our r. So what is n? That's the easy one. Okay, I thought that was the easy one. 15, yeah, 15 terms, so n is 15. What's a? Somebody said 1. Yes, it is 1. Do you guys see how it's 1 times 2 to the n minus 1? So a has to be 1. And then what is your r? 2. Okay. So we just have to plug those pieces in and evaluate it. So s sub 15 equals 1 times 1 minus 2 to the 15th over 1 minus 2. Again, I would like sort of not a fraction at the end, so let's just see what you get. So this 2 to the n minus 1, couldn't that be 1 times 2 to the n minus 1? That's a times r to the n minus 1. Like, the 2 is the r. Like, whatever is being raised to the power, that's your r. Do you see it, like, up here in the formula? A, so that's what we're just getting our pieces from. So, S sub 15, what'd you guys get? Good, perfect. Okay. R's 2. Are we struggling on finding those pieces?
Yeah.
So this 2 to the n minus 1. We had the formula up above. We had a sub n that was a times r to the n minus 1, right? So this right here, this 2 to the n minus 1. 1 times 2 to the n minus 1. Do you see how the pieces match up now? So like A has to be 1, R is 2. So you just have to think of it in that format. You good? Alright.
So you find like the first two.
No, the R is just right. Like R is there because it's R to the n minus 1. Like R is whatever's raised to the n minus 1. Okay. We all right? Okay, let's keep going here. All right, if we are looking at infinite geometric series, so those are the ones that go on forever. It's a series though, so we're still adding. Those actually can converge or they can diverge. Converging means you can actually find the sum, which seems strange since it's infinite. But if you think about a graph, think about something that goes like this. It's really, really, really close to 0 at the end. Okay, so what you're adding becomes insignificant, and you can find the sum. So that's why it converges. Something that's going to grow exponentially, though, are you going to be able to find that? No, because it's just going to get too big. So what you look for to determine which one of those we're looking at is the R value. If the absolute value of R is less than 1, it's going to converge. If the absolute value of R is greater than 1, it's going to diverge. It's going to go away from it. If it converges, we have this formula to find what the sum actually is. So even though it's infinite, we could still find the sum if it converges. All right, so look at these three. I want you to just label them as diverges or converges. So pick those three, look at them, which ones diverge, which ones converge. Remember, we just look at the R to decide if it's divergent or convergent. I don't have any of the new updated ones because I don't teach an SOL class, so. Yes, I'm trying to think if they're going to take it away from me though during. Because every single one of those that any teacher has gets taken during SOL testing and like the practice leading up to the SOLs. So like beginning of the year, that would have been a fine solution.
No, just a blog.
Just today? Yeah. That's what I'm saying. They're not going to have it every day that we do this. Do you have a friend who you can borrow from during the first period? Yeah, I would start there, just because we're getting, like, beginning of the year, that would have worked out great. Now that we're getting into, like, AP and SOL testing, those calculators aren't going to be around. So I don't want you to be depending on it, and then your teacher will be like, oh, they've been taken for SOL testing. Okay. All right, guys, first one, what do you think? Diverge. Second one. Yes. Third one. Okay. So let's find the sum of this third one since it converges. We need the A and the R to figure it out. So what is A in this one? Okay, what is R? So the sum, you need to just do 3 over 2 over 1 minus 2/3. Let's do this one by hand just because you need practice with fractions. So what is 1 minus 2/3?
1/3.
1/3, good word. All right, fraction over a fraction, what do I really do? Yep, so 3/2 times 3 over 1. So the sum of this would be 9/2. Okay. So I'll give you a question and I'll say, if the sum exists, find it. So you have to understand if it's divergent or convergent first, and then use that formula. It's a pretty basic formula, but yes, it is one more than you need to know. Okay, so that's only for infinite geometric series. Would it work for infinite arithmetic? I mean, I know we wouldn't have the R, but could you find the sum of an infinite arithmetic sequence, or I guess series? No, because you'd be like adding 2 every time. Like that's never going to converge. That's just going to keep growing or keep decreasing. So it's only with infinite geometric series that you could possibly find the sum.
And it would have to be convergent.
Yes. Yep. All right, we okay with that? All right. Let's look. We've got just 2 left here. So, you know what? Let's jump to the last one just for time's sake. So we'll skip this little convergent one and we'll do the ball one. So we have a ball. It is dropped from a height of 30 feet. Each time it strikes the ground, so when it bounces up to 0.8 of the previous height. Okay? So we need to write essentially the rule for this. So let's think about it. We're going to write the summation formula. Are you guys okay with me starting at n equals 1? Okay. It bounces, it goes up 0.8, it bounces, it goes up 0.8. In theory, could it keep bouncing forever? 0.8, 0.8, 0.8. It's going to get really, really small, but okay, so we could go to infinity, right? And then let's just write the rule for this. So, what is the initial term, or the initial height of this? Yeah, 30. What's my R? 0.8. Okay. To the n minus 1. Everybody okay with that? All right. 30 minus n times 0.8. No. Because it's 0.8 of the new height. You know what I mean? Okay. All right, so what height will the ball reach after the 3rd strike of the ground? So what am I actually looking for there? Yeah, a sub 3. And we can use this formula we just wrote. So go ahead, key that into your calculator, see what you come up with here. Yeah, that's what that says. It's really small. My 3 does not look like a 3.
So it's 32.8 squared. And we just do like a really
Because it's not like it bounces point
Because that would make sense, right? Wouldn't that be weird if it's bounce, bounce, and then all of a sudden it's way up here? Okay. That's why we have that formula of A over 1 minus R. For this? No, you were just supposed to do 30 times 0.8 to the 30 times 1. Like you're finding one specific term, that's if you're finding the sum. Like if I said, what was the total distance the ball traveled after 5 bounces? Okay. Yeah, I could possibly put those infinite ones on the non-calculator part though, so yeah. Yeah. All right, guys, part B, what's the height after it strikes the ground for the nth time? Well, that's the formula we just wrote. So A sub n equals our 30 times 0.8 to the n minus 1. Do you guys understand how that's giving you one specific height? Like after the 6th bounce, this is what the height of the bounce is, not all the bounces together. Maybe. Okay, so that formula, like A sub n equals 30 times 0.8 to the n minus 1, that's giving you one specific height of a bounce. Okay, so like the first question there, how high is it going to bounce after the 3rd strike of the ground? Okay, we're just finding like one height. We're not saying after 5 bounces it traveled this much total distance. Okay. How many times does the ball need to strike the ground before its height is less than 6 inches? So what would we do? This would be the 6th.
So if it's in would be 2.5.
Was it all 30? Yeah, you're right. So you would do 0.5 over here too. And you would have to solve that equation. You guys remember how to solve equations where the variables in the exponent? Okay, so the height was initially in feet, right? 30 feet. And then it says when is its height less than 6 inches? That's half a foot. So we're putting 0.5 in instead. So you'd have 0.5 over 30 equals 0.8 to the n minus 1. Then you could take the natural log of both sides. So natural log of 0.5 over 30 equals n minus 1 times natural log of 8. Okay. You could divide by natural log of 8 and then add 1 to that. Does that make sense? So you have natural log of 0.5 over 30 over natural log of 8. 0.8, right? I lost my decimal. 0.8. Then add 1, that's going to equal your n. You can also guess and check, yeah. Because it's not, it would be one specific, like you're not going to give me a decimal. It'd be like, okay, 6 times, 9 bounces, 12 bounces, whatever it is. So you should come up with 9 bounces. It comes out to like 8.2 something, which we can't have part of a bounce, right? Yes. So it's n minus 1, right? See how this comes in front? So I divided by natural log of 0.8, and then to get n by itself, I have to add 1. I was just doing algebra all at once. I know it's tricky. Are you guys getting 8 point something? Which would have to be 9. Uh-oh, Paige, no. Let's see your calculator.
I didn't know how to go arms. I was like, check this out. No.
Like 19.
Yeah, I got 21 out of it.
Guys, I'm getting like 19. Let's look at this one again. We'll come back to C. So, really, I'm getting like 20 bounces. All right, let's look at D. What is the total distance the ball travels before it stops bouncing? I'm asking you the summation of an infinite geometric series. So do we have a formula for that? Yes, we can only find that sum if it actually converges. Does this converge? Yes. So we've got our formula up here. It's A over 1 minus R. Because guys, you can't put in that infinite sigma in your calculator. Okay? That's too bad. What if I made you do this without a calculator? Then no, you could not. And guys, I think this example helps you understand how you could actually find the total height. Because that ball bouncing, even though it in theory keeps bouncing forever, doesn't it become so minuscule that you're not really changing the height at the end? 0.8 of something really, really small ends up not really doing anything. So the total the ball bounces, you can actually find. Are you getting 150 feet? Yes, okay. All right. So we'll get back to C next time. Just to double check. All right. Part of it. Part of it. So guys, we're going to start with the puzzle side of this. What do you call spooky sausages? Lovely riddle. All right, guys, so what we're going to do for your homework, you have the puzzle side, and then on the back, I'm going to have you cross out a couple of these. For 2, the second part, it says give answers correct to 3 sig figs. We're not going to do that. You're going to do 3 decimal places right now. Part number 2, it says 3 sig figs. Change it to 3 decimal places. Cross out number 4. cross out 11, and then cross out 12. Okay, but let's not do any book problems this time.
Just this.
Yeah, so front and back of this worksheet, crossing out 4, 11, 12, and changing directions. Okay?
4, 11, 12.
Gone. Gone. Don't do that. Okay. Yeah.
First one says 5 curve. It says 9. But just ask me the
Yeah. No. Yes.
Like, what is it?
Yeah, it's just saying evaluate it within its own.
I can't think about high speed chains.
No, that would make way more sense. Nobody got a worksheet that only has one side, do they? Okay, just repeat it.